Hello everyone, welcome to week 8. It is the last week that we're going to be doing these type of notes. Next week we start our CPTs. This section is an extension and we've decided that we're not going to make an assignment at the end of this because although we are delving into the quadratic relations, we're not going to be going overly crazy with it. It's an idea to get you to understand about quadratics and be prepared to start the grade 10 stream next year. So let's get going. So if you remember in grade 9, we talked about linear and we kept hitting the point that it was a degree of 1, meaning the exponent on the variable is power of 1. It will produce a straight line on a graph. How do I know? Plug in a bunch of points on the x side, substitute in, solve for the y. Take a look on the right side here. Grade 10 material, that's why it's the extension. As soon as I have a degree of 2 makes it a non-linear equation. The only way I can prove that to you is if you were to do table of values. So here's my table of values, and you'll notice that I used the same x on both tables. Okay, well, with regards to the linear side, you'll notice that they have a common difference, common difference of 2/3. And you'll notice that I misspelled the word linear. Oops. You go and correct it for me. Thank you. On the grade 10 material, when I do my first difference, you'll notice that my first differences are not the same. Because first difference, degree of 1, is not the same, it's not linear. If I did the second degree, and again, you start at the bottom and you subtract as you go up. So 5 minus 3, 3 subtract 1. 1 subtract negative 1. Negative 1 subtract negative 3 makes it plus 3. You'll notice that the second difference is consistent. Second difference, quadratic, because it's the second degree, not the number 2. That's not important. But it is a difference. Second difference is the same. All right, so now hopefully we know from table of values, first difference, second difference. Let's see what happens. If we were to graph all these, now with the linear one, I didn't bother to show you every point because we've done enough of the linear. But if you notice, these points are lined up properly. What I'd like to point out is being a quadratic and being second degree, it forms what looks like a U shape. All right, well, different people describe it different way. Think of Superman grabbing a pipe and between his two hands and pulling it tight makes a nice U shape. There's the Superman pull. Also, you want to notice that there is a line that will go through the middle and it splits identically on both sides of this center. Well, this center is called the axis of symmetry. It is symmetrical about both sides. We'll get back to that. All right. I would like you to note a bunch of things. For example, degree of 1, straight line, linear. Notice I spelled it correctly here. Degree of 2, nonlinear. 1 bend. Degree of 2, 1 bend. This is known as the quadratic. But when you see this U shape, they call it the parabola. The y-intercept. The y-intercept does not care what degree you're talking about. It is the y-intercept and it will cross the y-axis if it exists. When x equals 0, or the coefficient with no x, That is your y-intercept. All right, let's keep going. Just to sort of highlight everything together. Ready? Grade 9, the linear side, right? Standard equation, ax plus by plus c equals 0. Quadratic side, standard equation, y equals ax squared plus bx plus c. On the linear side, we had the semi-standard, ax plus by plus equals c. On the quadratic side, we have something called the root version. Y equals a times bracket bracket. This is known as the root form or zeros form. It's called the roots or zeros because it is the x-intercepts. There's two of them here. You'll learn that probably next year. Last but not least, y equals mx plus b, slope-intercept. It's a special way to write the equation of a line. Well, quadratic, not to be undone, also has a special way to write its equation. This is called vertex form. And what it does is it gives you the vertex by reading the h and the k. Linear, again, all degree of 1. Quadratic, degree of 2. Next, I'd like you to spot the equation. I have equation number 1, equation number 2, and equation number 3. I would hope that by looking at the numbers that you see in front of you, you can tell me what degree is it, parabola or linear, y-intercept. And all that should be just by looking at the equation. For example, equation number 1, degree of 2, parabola. Y-intercept, 1. Now what I'm going to teach you is a bunch of stuff about the quadratic. That'll come in a minute, all right? Next, y equals 5x minus 3. Well, that's degree of 1, so I know it's linear, and it crosses the y-axis at negative 3. Last but not least, 5 minus 2x squared. It's still a quadratic because it's still degree of 2. It doesn't matter that the 2x squared is not in front. And 5 is its y-intercept. So let's see if we're right. Look at that. Okay, now, important parts of a quadratic. If I give you the standard equation, y equals ax squared plus bx plus c, the a, the b, and the c are just coefficients, numbers in those positions. They could be a plus or a minus. The a factor does two things for us. It tells us the direction of opening. For example, if a is positive, the parabola opens up. Positive, smiling, right? Because people are positive. If a is a negative, then the parabola opens down. Think about it. If a is negative, you've been negative with a kid, they have a big frown on their face. Okay, so their frown looks down. Degree of 2 tells me parabola. Y-intercept is where it crosses the y-axis. All right, so what I did was I came up with a very generic looking parabola. Vertex is the optimum location. This is why parabolas are important. When it's opening down, right, this gives us its lowest point. And this line going through the middle, the axis of symmetry, tells me when the lowest point occurs. So when it's at the bottom, it's considered to be a minimum. That's its minimum value. It will never get any lower than this vertex. That's what it means. Since we've started with the vertex, let's deal with it. This line cutting through the vertex is known as the axis of symmetry, and it cuts the parabola in half. The reason that's important, the axis of symmetry is actually the x half of the vertex location. This x tells me when the vertex is going to occur. The y side is its value. Okay, how much this y value or this vertex is worth. Now, it's at the bottom of this particular equation. Okay, it's a minimum value, and I'll know how much if I had some numbers here. Okay, let's say -9, just because. All right, let's continue through. See point C? I used letter C because I want you to remember that that's where it crosses the y-axis, the y-intercept. Now, there are 2 point D's here. Now, it doesn't always have to happen. This particular parabola opens through or across the x-axis. So these point D's are the x-intercepts, but they're also called the roots, and they're also called the zeros. All right, so they got 3 names, all mean the same thing. All right. There's no single page of homework in any textbook that will give you the bits and bytes that we're doing here. Let's finish this example. Now, this time, I'd like you to fill in the spots. Ready? Here's the equation, and here is the parabola that it will draw. Degree of, tell me. Degree of 2, okay. How do I know? I look at the equation, or I look at the graph. It's not straight. Degree of 2. One more thing about looking at the picture, it can only have one bend. Hopefully I'll see you in my advanced functions class, and I'll tell you what happens when there's 2 bends, 3 bends, but for today, 1 bend. Okay, so degree of 2, so it's nonlinear or quadratic. You may want to write the word quadratic in here. The vertex. Well, when I look at my diagram, I read it off the graph. And right now, my vertex is sitting at 3, 4. Okay, 3, 4. The a factor. Well, the a is -1. It's the number in front of the x squared. Because it's negative, that means it opens down. Excellent. Equation of the axis of symmetry. That means if I were to draw a line right through the vertex, which splits the parabola in a mirror image on both sides, that would be x equals 3. So that's my axis of symmetry. It is a maximum this time because it is opening down. Its value is 4 because that's as high as it got. Nothing higher. The y-intercept. Okay, well the y-intercept looks like -5 in the picture, but all I had to do was look at the equation. Okay, -5. The roots. The roots is where it crosses the x-axis, and it does cross. +1 and +5. Now, you can write them as x equals 1 and x equals 5, or you can write them as coordinates. 1, 0 and 5, 0. Be prepared that every teacher says both. The rest of this, take a look here. Equation 1, equation 2, and equation 3. What I'd like you to do is I'd like you to fill in this table. Degrees, direction of opening, y-intercept component, what's the vertex, the axis of symmetry, and so on and so on and so on. Last but not least part of our lesson. I wanted to give you an example to show you that you don't have to have nice numbers like 2, 3, and 4. Here are some nasty looking numbers. Now, if you were to use Desmos, and I would hope most of you do, you'll see that this equation is pretty close to graphing this. Reason? I use Desmos too. Anyway, so here's an equation of the water coming off a fire truck and the angle that it's going to take. How high is the water hose from the ground? Okay, well that's a word problem, but think about it. If it's off the ground, T would be 0 and it'd be on the top of the truck, so 11.7 feet. How high will the water reach? Well, that's its vertex. It will reach 20 feet off the ground. When will it happen? 10 feet away from the truck. How far away from the truck? How far away from the truck if the wind, oh boy, bad English. You can tell I'm getting tired. All right, so how far away from the truck does the water have to be if it's going to hit a window 18 feet above the ground? Well, what I'm going to do is I'm going to climb up to 18 feet, slide across. Okay, now this one doesn't make sense. I mean, the building could be 5 feet away, and I'm going, if it's going through this particular window, the water's going into the ceiling, right? But if I continue the 18 feet to the other side, 15 feet away from the truck, now the water's gone up and is going down through the window. See it? It's on its way down. All right, last but not least, if there was no building in the way, how far will the water reach from the truck? Well, I look at where it crosses the x-axis because my truck tire would be down here, right? On the x-axis. This is why the roots are important. The root tells you when it hits the ground level. Had this been a rocket, had this been a soccer ball being kicked off a roof, a football being kicked out of the hands, all those type of questions that follow this type of pattern. All right, ladies and gentlemen, I left you with some homework, not much, and what I'd like you to do is start to prepare for your first chapters that we saw at the beginning of the semester, because that's the first half of your CPT. Thank you very much.